Welcome to today's GATE video, and myself P.SENTHIL, Assistant Professor in the Department of Information Technology under S.A.E. Engineering College. And today's topic is about Dijkstra algorithm using greedy technique, and this topic will comes under that algorithm. So first we get into the deep introduction about greedy technique. So greedy technique is in the given complex situation. So we can able to solve multiple problems which is very unique in nature, and it going to give the best solution for the given any complex problem. So in that we are going to use Dijkstra algorithm. So in Dijkstra algorithm we are going to find the shortest path between in the given network. So it going to calculate the shortest path in n number of nodes. And also in Dijkstra algorithm, other name for Dijkstra algorithm is straightforward algorithm, which is gives a very straightforward solution in a given complex problem. And now we moving with the process of Dijkstra algorithm. Here you can see about a given graph. So you have n number of nodes here. So it will start from A node and it will end to Z node. So you will have n number of nodes. The main algorithm says that we are going to find the shortest path from the starting node A to other nodes, neighboring nodes. Okay, so here we are going to give a best example for here. We have totally we have 6 nodes here: A node, B, D, E, F, and C. So my process is about the starting node. Let us consider my starting node will be A. Okay, so my ending node will be C. So I am going to identify the shortest path from the starting node to all other neighboring nodes. So in real-time application, Dijkstra algorithm mainly used to find the shortest route. Let us consider A is in a city, and B, the remaining nodes B, D, F, E, and C are the remaining cities. So as we go with the Google map, we will find the shortest path. Okay, the same application that we are going to use in Dijkstra algorithm. Here the starting node will be A. So first we are going to see the immediate node. The immediate node will be B, and the next immediate node will be D. So as you all know, the immediate node B and D, we are going to find the shortest path. So in Dijkstra algorithm there will be no negative edges. So negative edges means there should not be any negative values in the given network. So that is the main drawback in Dijkstra algorithm. Because why? So if you are going to give the negative edges values, we cannot identify the shortest path. So that is the main issues in Dijkstra algorithm. So first we go with A to B. So A to B will have the weightage of 2. Another path will be there, A to D and D to B. So A to D will be 8. So D to B will be 5. So 8 plus 5 will be 13. So the shortest path will be A to B is 2. Okay. So that is the first thing. And here we are going to start from A. Simple table is going to be displayed, and the first column will be the number of nodes. The second column denoted the shortest path distance, and third column represent the previous node. Okay, the destination node, which destination node we are going to end it, and what will be the previous node of the destination node. So that will be mentioned here. And first it will start from all infinity, because now only we are going to identify the shortest path. So first we start with A, as I told you before. So now you can see, so A to B and A to D. So A to B is the shortest path because the value will be 2. Now another that, as I already told you, A to D and D to B, so the value will be 13. So among 13 and 2, which is the least value? 2. So this is the shortest path. So from A to B, the value will be, the weighted will be 2, and the node will be A. So because A is the destination node and the node previous node will be A. A, B is a destination node and the node previous node will be A. So the value will be 2. And the previous node will be A. Next we go on to the next nearing node will be D. So there will be a two path. The first path will be A to D, which is a direct path. Here the value will be 8. And the second path will be A to B, B to D. The value will be 5, 5 plus 2, 6 and 7. So the value will be 7 and the second value will be 8. So which is the least value? Okay, the 7 is the least value. So that for D, we are going to use A path. Okay, for D, we are going to use the A path. So which is immediate value will be 8. So 8 will be here and the next previous node will be A here. Okay, as I mentioned here, is again automatically we will find this path will be 8 and this path A to B, B to D will be 5 plus 2, 7. So as I told you before, so this path is 8 and this path is 7. We are going to identify the shortest path, that is the Dijkstra algorithm. So the value will be 7 will be the least value when compared to 8. So I am going to use this path A to B, B to D. So the value will be 7. So 7 and the previous node will be B. So for the D is the destination node and A is the starting node. So the previous node, which node the path is going to be using. Okay, so that path the previous node will be B. Okay, so that is B. So now we have finished A to B and A to D. Next we are moving to A to E and A to F. So these two nodes we are moving on. Let me see for A to E and A to F. So what are the possible path we will see? First we go with outer path. Okay, A to B and B to E. Okay, 6 plus 2, 6, 7 and 8. The value will be 8. That is the one path. And A to D and D to E. Okay, so A to E will be 8 and D to E will be 3. So that will be 11. Okay, that is the second part. Third part will be A to B, B to D and D to E. So A to B will be 2, B to D will be 5, 5 plus 2, 6, 7, 7 plus 3, 10. So we among these values, the shortest path will be A to B, B to E. That is 6 and 7 and 8. So 8 is the shortest path. So as I told you, for E, 8 is the shortest distance and immediate node will be D, because we are going to use this link to E. So the immediate previous node will be D. Okay, so that we will use D here. So we have finished this A node, then we move on to F node. Okay, so the first for the F node, so we have to identify what are the different paths we are having. So we will go with A to B, B to E, E to F. That is one path. The second path will be A to D, D to F. That is the second path. And third path will be A to B, B to D, D to F. That is the third path. The fourth path will be A to B, B to E, E to D, D to F. So totally we have fourth path. Now we are going to identify among this fourth path which path will give the minimum weightage value. Okay, first we go with A to B, B to E, E to F. Okay, so 6 plus 2, 7 and 8. So 8 plus 1, 9. Next A to B, B to D, D to F. That is A to B will be 2, B to D will be 5. 5 plus 2, 6 and 7 and 8 and 9. So the 9 will be the shortest path. Next we go with A to D and D to F. And so for the A to D, there will be the value will be 8 and D to F the value will be 2. So 8 plus 2 will be 10. So among this path for the F, so 9 is the shortest path. We are going to use the D value, that is A to B, B to D, D to F. That is 5 plus 2 plus 2. This is the shortest weightage path. So we are going to use this link. Okay, so 5 plus 2 plus 2, that will comes 9. So once we find the shortest path F, so the immediate previous node will be D. So that is the immediate previous node will be D and my shortest path will be 9. Okay. So now, as of now, we have find the shortest path from A to B, A to D, A to E and A to F, and the last node is A to C. Okay, so let will see the last node will be A to C. So first we have to identify the how many paths are there from A to C. Okay, so first we go with outer path. The outer path will be A to B, B to E, E to C. That is the first path, first outer path. Second outer path will be A to D, D to F, F to C. That is the second path. The third path will be A to D, A to B, B to D, D to E, E to F, F to C. That is the third path. And fourth path will be A to D, D to E, E to F, F to C. So totally we have 4 paths. The same logic that we are going to using here. We are going to find the shortest path. First we check with the outer path. That is A to B, B to E, E to F. So 2 plus 6 plus 9, it comes around 17. And A to D, D to F, F to 3. So that is 8 plus 2. So 8 plus 2 plus 10. So 10 plus 3, 13. Okay. Next we move on to A to B, B to D, D to E, E to F, F to C. We will calculate. So A to B will be 2 and B to D will be 5, 5, 6 and 7, and 7 plus 3, 10, 10 plus 1, 11, 11 plus 3, 14, which is highest value. So finally the least path will be this path. As I told you, A to B, B to D, D to F, F to C. So now we can calculate the path. 5, 6, 7, 8, 9, 9 plus 3, that is 12. 12 is the shortest minimum weightage that we are going to calculate. For the C is the destination node. The immediate previous node will be F. Okay, for that we are going to use F. So this is how the Dijkstra algorithm will be using. So this is the best application for in a country. We are going to moving to from one city to other city. We will use the Google Map here. So Google Map shows the shortest path. So the shortest path concept will be using this Dijkstra algorithm. That is a real-time example. Now we moving with the gate questions. Okay, so the first question is Dijkstra algorithm follows which design paradigm? So which design that we are going to use? First option will be dynamic programming. Second option will be greedy algorithm. Third option will be divide and conquer. The fourth option will be backtracking. As I told you, a Dijkstra algorithm concept will be using under greedy algorithm technique, which is very unique in nature. For any complex problem, this greedy algorithm will be used. The option will be B. The second gate question, which of the following statement is not true about Dijkstra algorithm? So now we are going to identify the given statement which is not true. Okay, so first we go with A option. It required non-negative edges weight. As I told you, it should not have any negative edges, so it is non-negative, and this first option is correct. The second option, every time we select the unvisited vertex with the smallest tentative distance. Yes, we are going to find the smallest distance. We are going to calculate the minimum weightage. So second option is also correct. Okay. We go with the third option. It also passes through the least number of vertex. It going to also passes through the least number of vertex. Not we are going to find the shortest distance. We are not going to find the least value. Okay. So I think option C will be not correct. But we go with we'll check the option D also. So it computes single source shortest path. It computes the single source shortest path. Single source at a given distance, at a time it will find the shortest path between the two nodes. So this D option is also correct. So the wrong option will be C. Okay. And next we move on with the third question. Which data structure is most suitable for implementing Dijkstra algorithm to get good performance? So which data structure algorithm that we are going to use? First we go with stack. stack we all know, so, and circular queue, minimum priority queue, and linked list. So all this stack, circular queue, and linked list will have the different concept, but which is very unique in nature is minimum priority queue. So minimum priority queue, among the given algorithm, given path, we are going to find the minimum shortest path. So this the data structure concept that we are going to use, that is mini priority queue. Okay, that is the option C is the correct answer. And move on to the fourth question. In Dijkstra algorithm, which operation is not necessary? So in Dijkstra algorithm, which operation is not necessary? We are going to find. So first we go with option A, extract minimum, selecting the unvisited vertex with least tentative distance. This is the correct option because we are going to find the shortest path. Second is relaxation of edges. So relaxation of edges means we are going to identify the each edges weighted. The second option is also be correct. The third option will be decrease key in priority queue. Yes, we are going to find the shortest path which is going to in the form of decreasing key concept. The third option is also correct. The fourth option that we are going to see about the backtracking to the previous vertex when a chosen path turn out suboptimal. So backward tracking operation we're not going to use in Dijkstra algorithm. So I think option D is the wrong one. So we check with the answer. So our answer will be D. That is the backtracking operation will not be implemented in Dijkstra algorithm. So we move on to the fifth question. Dijkstra algorithm cannot be applied if the graph contain. Cannot be applied, they are asking. So zero weightage edges, that is the first option. Negative weight edges, that is the second option. Multiple edges between the vertex, that is the third option. Fourth option will be self-looping. As I told you, Dijkstra algorithm will be working only on non-negative edges. So it given negative weighted edges. So this is the wrong option. This is the cannot be applied for the performance. So option B is the correct answer. So we move on with the question 6. So what they are asking is about in the given graph, we are going to find the shortest path between A to D. So first we are going to identify how many paths are there between A to D. So first we go with A to B, B to C, C to D, that is one path. The second path will be A to E, E to D, that is the second path. And third path will be A to B, B to E, E to D. And the fourth path will be A to B, B to E, E to C, C to D. So among these four paths, we are going to identify the shortest path. So first we go with the outer path, that is A to B, B to C, and C to D. So 7 plus 3, 10, 10 plus 6, 16. Next we move on to the next outer path will be A to E, E to D, that is 7 plus 1, that is 8. So far we have find the two paths. So among this, so 8 is the minimum value. Next we move on to A to B, B to E, E to D. So that is 7 plus 8, which is more than the weightage that we have find. The minimum value will be 8. So I think the option D is the correct one because among this four path, the shortest minimum path will be 7 plus 1, 8. That is A to E, E to D. So now we check with the answer. The answer is D. So D is the correct option, which has the minimum weightage of 8. So this is the last question what we are going to discuss about. Which of the following is not a properties of Dijkstra algorithm? Which we are going to find which is not a properties of Dijkstra algorithm. The first option works only a non-negative weightage, as you all told you. So this is the correct option because Dijkstra algorithm will be working on non-negative values. Okay. So the second option will be find shortest path from a single source. We have to find the shortest path from a single source, from a single starting node to the ending node. So option B is also be correct. And option C, can detect negative weightage cycle. No, it is a wrong one. As I told you before, it's going to work on non-zero values. It won't work on zero values. So option D is a wrong one. Okay. So far we have seen what is Dijkstra algorithm, how this concept will be working on. So we have discussed 7 questions, gate questions. So I hope you all understand, and thank you for watching this video. We'll continue in the next video section. Thank you.